All right, Ellie, this one, I usually get this one started on the same day as that one that was blue. You just got to base it on time, or maybe you're not even going to do this one, whatever the case. But I usually try to get this one on the same day, but usually we don't finish it just based on time, which is okay that it spills over into the next day. It's a good way to reinforce. But I start this one similar to what I did with the last one. Reminding the kids, put these tips up there. If they want to cut and paste it from the last sheet, they sure can. I see the value in writing. And nope, I did that wrong. There we go. So I think those are my reminders. If I remember any others, I will put them up there as we go. And again, I draw arrows. Again, the first couple, I draw arrows. Again, just so the kids are getting used to this. Just so that they're getting used to that. Now it's just going back and forth to their periodic table. Again, just like we did before, periodic table, they can find them. Find the different ones. There's boron with a mass of 5. Hopefully the kids are noticing, hey, how come there's 2 borons? Well, that's leading into the isotope idea, but tell them that doesn't change anything. Boron always has, and again, I'll work through boron together with them. Boron atomic number 5. So we take the mass number, I'm getting ahead of myself. So atomic number 5, 5 protons, 5 electrons, and then I'll write this on the screen for them. Mass number minus the protons equals the neutrons, and I should have 10 minus 5 is 5. So there's boron. And then I go to the next one. I'm sorry, and the kids are going to ask, well, how come there's multiples? Doesn't matter, kids. We still do it the exact same way. Don't let that startle you. Atomic number of boron is always 5. 5 protons, 5 electrons. No real magic there. But now notice, I take the mass number minus the protons, and I get a different number of neutrons. And that's okay, kids. We're going to see that. These are called isotopes. I mentioned those in the notes a little bit. We're going to see these more, but these would be considered isotopes. So there's boron, kids. Now do the last 4 on your own. And so then I give them some time. Again, I'm walking around the room, answering questions, helping them find Einsteinium. If you haven't found Einsteinium in a while, Einsteinium is down in the rare earths right down here. So there's Einsteinium, atomic number 99. But again, give the kids, several minutes or so to work on that. Again, go through it with them. I'm not going to collect this one. I'm not going to correct it. The next one that you're going to do on the next class day, that one is when I'll start actually, going through and actually assigning points because the kids are getting used to it. And if the kids complain to me, they go, oh, you're not grading this. Well, if you make a cake for the first time, I'm probably not going to eat it because it's not going to be very good. But by the 4th or 5th time you make a cake, now I want a piece because you've probably gotten really good at it. So I'm not going to grade these first couple because you're just practicing and figuring it out. Diagrams. So these are a little different. And so with electrons, something I've got to add and give this to the kids, tell them that the electrons are arranged in energy levels around a nucleus, just like the kids in the school are arranged in levels. We have freshmen, sophomores, juniors, seniors. So kids in our school are arranged in levels. Electrons are kind of the same. And so come on, screen. There we go. And so I just have them write this off to the side. And I tell them these are just things they're going to have to get used to. That we can only have 2 electrons in the first energy level. We cannot have more than that. If there's 3 electrons, you can't just try to wedge. It's not like a suitcase. You can't try to wedge that last electron in there. You have to go to subsequent energy levels. Second level is 8 electrons max. Again, if you have a total of 11 electrons, well, you'd put 2 in the first, you'd put 8 in the second, you'd have 1 left over. Well, you can't wedge that 1 into the second level. Scientists said it just doesn't work that way. You can only have 8, so 8's the max. Third level is 18. Fourth level is 32 electrons max, and that's the highest we go to. And then I'll tell them this. There's up to 7 levels that scientists know of, and 32 is the max. But generally with our diagrams, we stop at the 4th level. There's just not a need to keep drawing them in this fashion. They just get to be too big and too cumbersome. So I generally will not go above the 4th energy level. So tell them we're going to use these numbers, have them write them off to the side so they don't forget them. Again, these numbers, they have to start really getting into their brains. And so what I do for the kids, now I come over here and I say, kids, I need to remember those 4 energy levels. So I'm just going to write them over here. So my first 4 energy levels, 2, 8, 18, and 32. I'm going to get to that in a little bit. So boron 10, and this is how I do it. This is the mass number. Remind them. This is the mass number, kids, not the atomic number. If you confuse that for the atomic number, you just made this drawing a whole lot harder, and you're going to make life difficult. So remember, you gotta remember that that's the mass number, not the atomic number. And then you got to remember that the mass number is the protons plus the neutrons. So we're trying to use the stuff that we're talking about. You guys, we're not just going to talk about it and forget it. We've got to use it and keep going with it. I'm actually going to stop the video here just because it's easier to upload smaller videos, and then I'll just continue on with my next video.